Tanzania, dumisha uhuru na umoja, wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania.
Are you an ordinary diploma student who has been looking an online institution that can teach you the beauty of basic engineering scientific mathematics? Or are you an advanced secondary student who has been looking an online institution that can teach you the beauty of advanced pure mathematics or basic applied mathematics? Or are you a teacher who would like to implement the digital teaching or just teaching your students by using the digital technology? Or are you a parent or a guardian or a leader or a politician who would like to see the implementations of digital technology in teaching according to the curriculums and syllabus of the beautiful country Tanzania? So the answer of all those questions will be revealed in this session, and I would like to ask you that to stay tuned until the end. How are you, everybody who is watching this fantastic video? I'm glad to have you today. This is Olenjolai. I thank God by His own grace who have given me a gift of teaching and a gift of loving engineering mathematics, scientific mathematics, pure mathematics, basic mathematics, and basic applied mathematics. So I thank God by His own grace who have given me a citizenship of the kingdom of heaven, and also I thank God who have given me a citizenship of Tanzania. I am a Tanzanian, and I'm here in order to help and to change radically the mindset of the Tanzanians. So in this lecture or session, I'm going to teach you about the beauty of basic engineering mathematics, basic scientific mathematics for ordinary diploma students in different engineering fields, and scientific applied science field, applied science, pure science and applied science fields. And also I will be teaching you the beauty of advanced pure mathematics, and I'll be teaching you also the beauty of basic applied mathematics for advanced secondary students according to the syllabus and curriculums of United Republic of Tanzania. So I would like to ask you, stay tuned and stay connected and be serious, because we are here in order to add value in your mindset. So I would like to take this opportunity to welcome all our national and international students. I thank God by His own grace who have made me to be a local, a national and international teacher in mathematics for our present generations and future generations. And this is all about the beauty of digital technology or digital teaching, right? Just implementing and just teaching millions of the students at the same time by using the knowledge of the digital technology. Wonderful. So before even I go further into this program, I'm fearful before the presence of God. And I want to tell you that for me, I'm serving God in this industry of teaching because it's a gift that He has given me, and I have an assignment to serve the King of the Kings. So because of that, and I know even yourself, you are serving God in a particular aspect, I would like to join you in a minute prayer of Alpha Prayer to invite the owner of the program and the teacher or the great teacher of the teachers, who His name is Jesus. So let us pray. Our Father who is in heaven, we come before Your presence. We humble, we repent for all our sins, transgression, iniquities, and rebellions, Father, that we have committed before Your presence. Wash us, cleanse us by Your holy, precious blood, in order for us to enter into the holy of the most holy place, according to the book of Hebrews chapter 10. Father, thank You for the forgiveness of our sins, transgression, iniquities, and thank You for the cleaning us now and forever. Our Father, because You are the Father and You are the great teacher in this program, You are the great engineer in this program, You are the great advanced teacher in this program, You are the great advanced, You are the great diploma lecturer in this program, in the name of Jesus Christ, welcome right now to teach me how to teach your children and to teach your children who are watching this program anywhere at any time. Father, thank you because you are faithful and you are here and your presence is with us. In Jesus' name, amen. May God bless you. Thank you for joining me. Well, secondly, I would like to take this opportunity to welcome you into our online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai. Simultaneously, I would like to take this opportunity to welcome all our viewers and all our students into our Tanzania Online Advanced Secondary School in square bracket Olenjolai. Both of these schools are not existing physically, they're existing just, we call it, they're existing online. So you can access or you can benefit on these institutions or polytechnic institution and these advanced secondary students online. So we provide our contents online. However, that sometimes we can teach even physical students and combine the analog educational the analog teaching system and digital teaching system. It means analog is physical teaching. Digital, it means that there's no need for me to meet with you. Wonderful. Okay. Again, I would like to take this opportunity to welcome you in Department of Basic Engineering and Scientific Mathematics for this institution, Polytechnic institution, and Departments of Advanced Mathematics for the for Tanzania Online Advanced Secondary School in square bracket Olenjolaim. Well, the module of the day or the subject is called the differentiation and integration, or in some courses we call it the principle of counting matrices and differentiation, or in some of the institutions or college it's called the Caligulas. And in case of advanced secondary schools in Tanzania, the subject that you are going to cover is called Advanced Pure Mathematics and Basic Applied Mathematics. Why? Because the topic of the day is the topic that you are going to cover today is a cross-cutting topic. This topic is being taught to basic ordinary, to ordinary diploma students, is taught to advanced secondary students. So here it means that I forgot to write the topic. So this is topic. So the topic. So so this is might be topic 1 for ordinary diploma students, so topic 3. Okay, but also for basic applied math, for advanced pure mathematics, this is the 9th topic for the Form 5, and for the students who are doing basic applied mathematics, this is the 4th topic in basic applied mathematics for the Form 5. So this is the number. Okay, don't get confused with this number. So the topic that I'm going to teach you today is called the differentiation. Say with me, differentiation. 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 That's the topic that I'm going to teach you. Then I dedicate this content to the second year students in ordinary diploma in engineering and ordinary diploma in science, or in short in Tanzania and an actually called it NTA level 5 students. In addition to this group of students, I dedicate, or these contents will be benefiting 100% to all the Form 5, Pre-Form 5, Form 5, Pre-Form 6, Form 6 students who are doing PCM or PMC or PGM and or EGM, PCB, HGE, CBG, CBA, CBN, ECA. Those are the combinations. So it means basically these contents will benefit students who are pursuing 10 combination in United Republic of Tanzania. Well, so lecture. So this is lecture 1 or session 1. The name of the lecture is called the first principle. So today I have a good news about the first principle. Well, so I'll be using the syllabus and curriculums of United Republic of Tanzania. However, that the concept of differentiation is universal. So even for the international students, stay tuned, don't tune it off or don't be disconnected, because the concept that I'm going to teach in this program are universal. I'm going to teach with the big picture and covering different levels And regardless of your backgrounds in mathematics, regardless of the backgrounds in basic applied mathematics, regardless of your backgrounds in advanced pure mathematics, regardless of your backgrounds in basic engineering mathematics, regardless of your backgrounds in basic scientific science for ordinary diploma, I will try my level best, and God will help me to make sure that I meet your demand. And you know, God, what He's going to do is going to do greater than your expectation, because He's always great, right? So that's very important. Again, this is the digital education. Now the questions comes in the mind. How can you interact with me? That's a very good question. As I said, that we will be sharing our contents in this Polytechnic institution for ordinary diploma, and also in these advanced secondary educational schools, by using the digital technology, by using the online at this moment. So our digital students, or online students, or wireless students, we can call them, you can interact with us by asking questions as you continue to watch the lecture or the session. So how can you ask your questions? If you are watching this video on YouTube, then you can ask questions in the comment sections. Later on will be add some more interactive platforms of digital technology that students can interact with us by asking questions, and by giving us feedback, by using videos, audios, and even justify receiving the PDF files just in case of the homework. But for the time being, you might be accessing our contents on the YouTube channel. And we have an official YouTube channel for Tanzania Online Polytechnic Institute of Tanzania, and also we have official YouTube channel for Tanzania Online Advanced Secondary School in square bracket Olenjolai. So the key thing, it means that try to learn and try to adapt digital educational system, because it's the only one that will be passing from one generation to generation without the physical meeting between a student and the teacher. Are you ready to enjoy the beauty of digital educational? If the answer is yes, then now let me take you into today's lecture or session. In case you want to register yourself for YouTube, just click the button of subscribe, and I'll give you some more information later on. So are you ready? So take your scientific calculator, take your reference books, take your exercise book, and have a fresh mind and concentrate. Don't slumber, don't give up, don't be disappointed. I'm here in order to create a new history in your life. And God can do even greater than what I said. So let us go into today's session or lecture 1. So before just to start the lecture 1, the traditional teaching aids of Olenjolai is to give you the quick review of the previous session. So what the names of the previous session was named as lecture or session 00. So lecture, it means for ordinary diploma, we call them lecture, and for session is for advanced secondary student. So what did we teach you there? So the first thing that I've been trying to plant in your mind is the Olenjolai's big picture. Olenjolai's big picture of mathematics. And actually, I've been reminding you your journey of learning and mastering mathematics. That did not start today, did not start during your primary education. It has been starting from our birth or our childhood, even our baby care, before even we go into maybe a baby care school. So we've been counting people. So the issue of numbers or mathematics is actual in our life. So I've been just representing to you how this journey has been going on step to step up to the point where you are right now. Right? In case you missed it, then you can access, because these contents are available here. The second thing that I've been reminding you, or I've been just implanting in your mind, is the reference books. Reference books of what? So reference books of what? Of differentiation and integration, or principle of counting, matrices, and differentiation, and also reference books that you need for you to master what? Advanced pure mathematics for the Form 5 and Form 6, and basic applied mathematics for the Form 5 and Form 6. So reference books and materials. So reference books, materials, and notes. And the good news that I told you that myself as your teacher, I'm not only teaching you, but I spend much time to prepare the notes in order for my students to just to learn by listening, watching, and even writing, handwriting, right? Then the second, the next concept that I've been teaching you in the previous lecture or session is actually I've been teaching about what are the contents, okay? Contents of what? What are the contents of differentiation according to your level? What should you cover? What should you cover in differentiation according to your level? And just to remind you, remember that here we have something we call mathematics. And under mathematics, we say that we have so many branches, but one of the branches of mathematics is called the analytical mathematics, or analytical mathematics, or analytics, just we call it analytics mathematics. And in this branch of analytics mathematics, we have one of the branch that we call the Caligulas, okay? And this branch of mathematics called Caligulas, it can be split up and give us very important 3 topics. Okay, sometimes you can call them subjective in themselves. And the first one is called the differentiation. Okay, just to remind you, differentiation. And then the second one, I told you, we call it in mathematics integration. And the third one, we call it in mathematics differential equation. And the good news, according to the engineering perspectives or advanced perspective, except for students who are studying basic applied mathematics, we have to teach you all of these 3 branches of of Caligulas, because we need them in solving real life problems. So that's all about what we taught you in lecture 0. So let us go into today's content. So today the title is called the first principle. But before the first principle, I have to keep laying the foundation, the general foundation, the big picture of differentiation right now, right? In case you missed lecture 0 or session 0, you can access in our official YouTube channel that called it Online Diploma Polyinstitute of Tanzania _Olenjolaim. You'll access lecture 0, or you can access session 00, our session 0 in our YouTube channel called Tanzania Online A Level Seki School in _Olenjolaim, as just you may see downstairs. Okay, so ladies and gentlemen, let us go into today's business. So today, let me teach you, firstly, I'll be teaching you 6 concepts in this lecture. It is kind of intensive lecture and intensive lecture or session. So get prepared. The first thing that I would like just to deal with or to teach you is I want to teach you the meaning of the word Caligulas. So we have here, or we heard the word Caligulas for the first time. So myself, when I heard the word Caligulas for the first time, what comes in my mind, what does it mean? What the meaning of this vocabulary first, before even I learned what Caligulas contain. Alright, so that's the first question. And then the second questions will go in Caligulas and we find differentiation. Then I will teach you what the meaning of differentiation. Just let me give the overview. So the differentiation will be the second concept. The meaning of differentiation will be the second concept that we are going to cover in this lecture. But again, from there, I will teach you about why do we study differentiation. And then the 4th concept I will teach you about I will teach you about the first principle. And the 5th concept, I will teach you about the derivations of the first principle. And the last concept in lecture 1 or session 1, I will teach you about the standard notation of differentiation or standard notations used in calculus worldwide. Are you ready to go with me? So stay connected. So the fundamental question, and this is question 1 in the mind of Olenjolai and the mind of my of Olenjolai students. What is calculus? What is calculus? Okay, what the meaning of calculus? What is calculus? Well, there are so many definitions of calculus, but I chose to teach you, or to just to teach you 2 definitions. They can give you the overview. So we say that calculus is a branch. What is calculus? Ask your neighbor, pause the video and think, what is calculus? Before just even you start differentiating a function, so you're starting to integrating, or you're starting to solve differential question, ask yourself what the meaning of calculus. What does it mean? Okay? So calculus is a branch of what? Of mathematics, the queen of engineering. Because mathematics is the queen of engineering. Is a branch of mathematics that deals, so this is the branch of mathematics that deals with the finding. The branch of mathematics that deals with the finding. So this branch of mathematics that deals with the finding and the properties. Finding and the properties. Finding and properties. Properties, and what? And the integral. Properties and integrals. Okay? Integrals of what? Of function. Calculus is a branch of mathematics that deals with the finding and properties and integrals of functions by method. By what? By method. By methods originally based on the summation, of infinitesimal. Of infinitesimal differences. This is the first definition of the word calculus. By methods originally based on the summation, this is the keyword, of infinitesimal differences. Infinitesimal means that these are the small. So what is calculus? Calculus is a branch, so you can copy. And then once we're done, listen careful. Calculus is a branch. It's a branch of what? Of mathematics that deal with finding and the properties and the integrals of functions, not mangoes, not properties of oranges, no, of functions. By methods, by which method? By methods based, so we have so many methods, that means of methods originally based on the summation of infinitesimal differences. It's a powerful definition. My dear students, from now onward, you will enjoy the beauty of calculus for the rest of your life. So keep this definition in your mind. Right? Then tell your neighbor Olenjolai station. Remember that our online Diploma Polytechnic Institute of Tanzania square bracket OLENJOLAIM and Tanzania Online Advanced Secondary School in square bracket OLENJOLAIM focus on understanding. So these are the homes of students on understanding the concept. Our primary focus is understanding rather than cramming. So calculus is a branch of mathematics that deals with finding what and properties and integrals of the functions by method originally based on summations of infinitesimal differences. So the one of the vocabulary here is infinitesimal, infinitesimal. So infinitesimal, actually this is the combination of the two words, infinite, small. What does it mean? Infinite, infinite. Oh, let me do the correction. Do this correction. Infinite, infinite. So let me write it. Infinitesimal. Infinitesimal. Wait. Infinitesimal. Okay? Because of the length of the lecture, maybe we can cover some other concept in the next lecture, okay? But I'll be trying my level best to cover all the 60 contents. If I can manage, then we'll cover the other remaining contents in the next lecture or session. Infinitesimal differences. So this is the correct way. Infinite. So it means that, just to clarify before I give you the second definition of calculus, let me clarify this vocabulary, because it was a vocabulary for me also when I made infinitesimal. Actually, that this is the combination of two words, infinite plus small. What does it mean? So infinite, it means that no limit. Small means that small, the other means small. This is come from the word small. So actually, in calculus, we'll be finding properties and integrals of functions by methods originally based on summation of infinite small, right? So it means in calculus we'll be taking a large system or a large geometrical figure and then split it into small segments that we call them infinitesimal. For example, if I want to differentiate a functions that representing, or maybe a particular function, maybe for example a quadratic function, okay? Or maybe if you want to find the area of this exercise book, for instance, you want to find the area of this exercise book. So this exercise book is just like a box because it has length, width, and the thickness. So in case I want to find the area by using the concepts of calculus, I have to take this exercise book and split it into infinite small segments. And then if I sum, it means that if I use a calculus and find the gradient, or maybe and integrating the gradient or solving the differential equation of one small segment, then I can use the concept of summation of that small segment in order to find out the area of this exercise book. Wonderful. Do you understand? So that's the concept. Okay, I will teach you in detail later. I'm still building the foundation. Tell your neighbor, Olenjolai is building the foundation. So that's the first definition. Or some other references define the word calculus as what? Calculus is a branch of mathematics. So calculus is a branch of mathematics. Concerned with the calculation concerned with the calculation of instantaneous instantaneous rates of change. Calculations of instantaneous rates of change, instantaneous rate of change, and this rate of change we call it in bracket or differential calculus, and the summation of what? Summation of infinitely many small factors to determine some word, to determine some word, or in bracket we call it, this is all about integral calculus, because we have differential calculus and integral calculus. So this is the second definition of of calculus. What is calculus? Calculus is a branch. This is the keyword. It's a branch of of mathematics concerned with what? Concerned with calculation. Calculations of calculations of instantaneous rates of change. Instantaneous rate of change. It means that this is focusing on rate of change. Right? Rate of change, or we call it differential calculus. And what? Summation of infinitely many small factors that in mathematics we call it infinitesimal or infinitesimal to determine some word or integral calculus. So calculus is the branch of mathematics that dealing with calculations of the rate of change of functions and summations of infinitely small factors that we call them independent variables, right? Or just dependent variables, depends that we type of the function, okay? To determine the word. So that's the meaning of of calculus. So in calculus we have differential calculus, and we have integral calculus, and we have differential quotient. Just it means that we have let me just write this point for you. In calculus we have we have differential according to the second definition, differential calculus, and also we have we have integral calculus. Okay, integral calculus. And then differential calculus now is a combination of both differential quotient. Okay, so it means in calculus we have differential calculus and integral calculus. I'm still building the foundations. I'm not yet in the concepts of I'm not yet teaching you differentiation. Alright? Did you understand the definitions of the word calculus? Keep this. When you are first born, ask you this question in future. My father, my mother, what is the meaning of calculus? Then you should answer your questions without referring elsewhere. Why? Because you are an engineer, you are a scientist, you are pure mathematicians, or you are applied in mathematics. It means that you are applying mathematics. So at least the definitions of calculus should be in your mind for the rest of your life. Alright? In case you didn't understand, or you have some more questions in YouTube and you're watching this video on YouTube, don't hesitate to ask your questions in the comment section below. Okay, That is number one. Number two, the second thing that I want to teach you, let me teach you a brief history. This is brief. When I say brief, is brief history. Brief history of what? Brief history of Caligulas. Brief history of Caligulas. Brief history of Caligulas. And then I'll leave the assignment for you to go for the, means to read the real, means that the history of Caligulas. Brief history of Caligulas. The knowledge of Caligulas has been introduced into our world of today in 17th centuries. And you know, this has been done by the great mathematicians, but they are human beings like you and I. Do you know who are they? Sir Isaac Newton and a German mathematician who's called Gottfried Leibniz. Those are the two mathematicians who introduced this great concept that is changing the world over and over. It's a generational concept that will be solving real life problems from one generation to another generation. Not the brief history, that's all. So you can just learn where does it come from, how did these two mathematicians. But one thing which I want to tell you, these are the human beings like you. They had everything possibly that we have. But only, you know, our difference? The testing and the priorities. They prioritize on solving real life, and they prioritize on doing a responsibility or doing something that will live beyond their life. Because these are the dead man. How about you? What legacy are you going to leave in this planet Earth? Ask your neighbor. So he said that the concept of Caligulas has been introduced to the planet Earth by two European mathematicians in 17th century. In 17th century. So I know some students say that, okay, sir, now you are overdosing us. Will we find a question in the exam that will ask us the brief history of Caligulas? I know what you are asking yourself. Okay, it's a good point, it's a good thinking, but here we are teaching you how to understand Caligulas, and we'll answer all the questions that will be asked in the exam, but we have to teach you more than what you are going to be asked in the exam. So be patient. I'll be arriving where you are thinking about it. So the concept of Caligulas has been introduced to the planet Earth by two European mathematicians in 17th century. Were you alive in 17th century? I don't know about you. But I think that you are not alive in the physical world, right? Okay. So these two mathematicians are Sir Isaac. So this they did this. How about you? Sir Isaac Newton. Okay, Sir Isaac Newton of England. Or United Kingdom of England, or United Kingdom, or in short we call it of UK, and the Gottfried Leibniz. Gottfried Leibniz of Germany. or German. Or German. So simply they shared the credit for having independently developed the Caligulas. So they shared it. They didn't have communication like now that they can make a phone calls. They shared it, the credit of having independently, we say that independently, it is real independently developed the Caligulas. Ladies and gentlemen, this is the end of our brief history. In case you want to learn in detail about the detailed history of Caligulas, don't hesitate to go online and learn, for example, in Wikipedia or different online sources or different offline sources. That's the second concept that I wanted to cover. So here, the great mathematicians who contributed this idea are what? Sir Isaac Newton and Gottfried Leibniz. So we're focusing on Newton's and Leibniz's concept as a great mathematicians who introduced the concept for the first time. Okay? Do you have any question? In case you have any question and you are watching this program in YouTube, don't hesitate to ask in the comment sections. Even if you're watching this program in Instagram, so in Twitter, don't also hesitate to just leave the questions in the hashtag below. Okay, so the third concept in lecture 1 or session 1, now I want to teach you the meaning of the word differentiation. So you know now the meaning of Caligulas, you know now the brief history of Caligulas. So now, ladies and gentlemen, allow me to build a strong foundation of what? Strong foundation of what? Of the word differentiation. Let me build a strong foundation. So the next question, which will be question number 2 in my mind when I heard this word for the first time, and even this question should be commonly asked in your mind, what is differentiation? What is the meaning of the differentiation? Before you teach me about differentiation, tell me what does it mean? It's a vocabulary for me. Because when I was in ordinary secondary education, I never heard anything about differentiation in mathematics, unless for students who did additional mathematics. When I was in primary education, I haven't heard the word, the terminology differentiation. I just heard the word difference or subtraction, right? So I want to know first what the means of differentiation. Once I understand its meaning, then teach me what is inside differentiation. That's all. So to answer this question, we say that this is the response. Differentiation. Differentiation is a branch. Differentiation is a branch of calculus. Differentiation is a branch of calculus which deals with measurement. So this branch of calculus deals with measurement, of sensitivity, to the change of the function. Sensitivity to the change of the function. The change of the function to the change of the function value. This we call the output value. Output value. The function value, output value, with respect to the change. With respect to the change of what? With respect to the change in its argument. In its argument, or in bracket, we call it input value. Input value. Input value. This is the end of first definition of differentiation. So when I'm cleaning the second column of the blackboard, you can spend a few minutes to copy that definition before I explain to you, because I have prepared 3 definitions, but I will present to you in this lecture only 2 definitions. It doesn't mean that those are the only definitions of Caligulas. You may also refer some other reference books and find more other ways of defining the word differentiation. So before I present the second definition and explain this first definition, stop writing. Differentiation is a branch. So now, Caligulas was a branch of what? Mathematics. Differentiation now also it's a branch of what? Of Caligulas, which deals with what? So this branch of Caligulas deals with measurement. What the means of measurement? We taught you in physics before, the former. Measurement of what? Of sensitivity. How the rate of change of the function is sensitive. The sensitivity to the change, very important word, to the change of the function value. And this function value, it means output value in bracket. With respect to the change, with respect to the change in its argument or input value. So you have output value and input value. So simply, differentiation is a measurement of change, of ratio of change of the output value of the function to the input value of the function. In other words, differentiation is the measurement of rate of change. Not the rate of change actually, because when I say rate, it means that the denominator or the dependent variable is time. So simply, differentiation is the measurement of what? Of sensitivity to the change of the output value of the function to the change of the input value of the function. What does it mean? This is the meaning. In order to differentiate or to have derivative, or we call it differentiation, first of all, we should have a function. It might be either single variable function or multivariable function. And then, what it means of differentiation? Actual differentiation, it's a measurement of what? Of change in what? Output value of the function, because a function should have an input value and output value. So the differentiation now is if I take the output value of the function divided by the input value of the function. That's the meaning of what? Of differentiation. So it's a measurement of sensitivity of what? Of change of the function, or in bracket, output value to the change of the function, to the change of the argument or input value of the function. That's the meaning. So, if that's the case, there's a close relationship between the concept of differentiation and the concept of gradient that we taught you in coordinate geometry. Okay, or some other references define the word differentiation in this way. Differentiation is a branch of calculus which deals with study of rates of change, not rates of change for geometrical curve. For geometric curves and figures. This means determining the slope or tangent along a given directions of the curve. This means determining the slope or tangent along a given direction. Along a given direction of a curve. Along the given direction of a curve. Of curves. Along the given directions of what? Of curves. This is the second definition of differentiation. So differentiation is a branch of calculus which deals with the study of rates of change for geometric curves. And figures. This means determining the slope or tangent along a given direction of curves. That's the meaning of differentiation. Differentiation is a branch of calculus which deals with the study of rates of change for geometric curves and figures. This means determining the slope or tangent along a given direction of curves. So differentiation is a branch of calculus which deals with the rates of change, not rate. This S is very important because when you make this S, the word rate means that something over time. So rates of change. So it's a study of rates of change for geometrical curves. We have different curves in mathematics, we have different curves in engineering, we have different curves in economics, we have different curves in research, we have different curves in business, we have different curves in financial, we have different curves in communication, we have different curves in technology. Okay? So it's a study of rate of change for geometrical curves. And study of rate of change for geometrical figures. This means determining the slope, so we'll be determining the slope or tangent along a given direction of the curve. So in differentiation, we'll be focusing on two things: determining the slope of the curve, of the geometrical curve or geometrical figure, and determining the tangent along a given direction. Later on, also will teach you how we can determine the normal of the curve. Are we together? Do you understand? That's the second definition of 40 of differentiation. Would you like me to give you a bonus? Let me give you the third definition of Caligulas, or of differentiation, because this is the cornerstone, or this is the foundations of our module or subject. In other words, we can define the word differentiation as follows. So in mathematics, differentiation can be defined as a derivative so can be defined as a derivative of a function with respect to an independent variable. Independent variable of a function. Can define differentiation in this way. Differentiation can be defined as what? Derivative. Aha. So that's why that we'll be using two words. Differentiation, the word differentiation is also, the synonym of the word differentiation is derivative. So we may say that differentiate or find derivative, or differentiate or find the derivative of the function. So derivative, it means that there's a synonyms, it means that whenever we say differentiation, we have the same meaning with derivative. So defined as derivative of the function, so it's a derivative of the function with respect to an independent variable of a function. Maybe you heard this word independent variable, input value, whatever. For example, let me take a simple function, a simple linear function. F of x is equal to x plus 1. Or in the other way, we say that y is equal to x plus 1. This we taught you in O level. So in this function, x is called the independent variable, and y is called the dependent variable. So simply we say that according to this third definition, differentiation is a derivative of the function with respect to independent variable. What does it mean? It means if I can find the change in y of the curve to the change in x of the curve, this is what it means differentiation. It means that this is a small change in dependent variable to the small change in what? Independent variable. Are we together? Are we together? Do you understand? If you have any question, don't hesitate to ask in the comment section below. I believe that you understand. You understand and you love. Your graph of loving mathematics is going steeper. So again, because we'll hear this interchangeably, the synonym of the word differentiation is derivative. So for some other students, the word synonym might be a vocabulary. So it means if the word differentiation, you can call it a derivative. What do you mean in this sentence? It means that when you say that the word differentiation is equal to the word derivative. Find the derivative of the function, means differentiate the function. Okay, that's the meaning. But again, another thing that I want you to be informed, to be aware, is this. Differentiation according to Sir Isaac Newton and Proust, differentiation is the fundamental. This is the fundamental tool of what? Of Caligulas. So it's a very important tool in Caligulas. Okay, so do you understand now about the meaning of the word differentiation? If the answer is yes, let me know in the comment section. If you still have some more questions, don't hesitate to ask me in the comment section. Okay. Remember that I'm building the foundation. Tell your neighbor, Olenjolai is building the foundation of differentiation in your mind. Tell your neighbor right now. Whether through the SMS or physically if you are learning at the group of students. And tell yourself, Olenjolai is building the foundation of differentiation in my mind, my face. And let it be like that. Okay, so that is the third word. Do you remember where are we? We are in third concept. The first concept, why do we study differentiation? Very important question. This is according to the way I learned this stuff. And I want to tell you that more than 85% of what I'm teaching you, I learned from my own mistakes. I struggled too much on understanding the topic of differentiation when I was in advanced secondary education more than 15 years ago. Is it 15 years? Yes. More than 14 years ago, I could say that. Yeah, more than 15. Okay, almost about 15 years ago. Okay? So I have made so many mistakes in exams, in my private studying. So all of those mistakes gave me a challenge to sit down and dig in. And then from there, you know that the gift of teaching was real burning my heart. So I said, I don't want other students of the present and future generation to do the mistakes or to experience the unnecessary mistakes that I've experienced myself in this stuff. So I have been writing down and digging time to time about differentiation for the rest of my life. And even up to this moment, I don't know everything about differentiation. I'm still learning, and my learning journey will never stop. I just know a small portion of differentiation, and I have an assignment to teach others about what I know. Right? How about you? Okay, so that was just a pause. So now let us come into the first concept. Why do we start? Okay, why do we start? Why do we start differentiation? Why do we start differentiation? So this might be a question we have. Why do we start differentiation? We put a question mark. Why do we start differentiation as engineers? Why do we start differentiation as scientists? Why do we start differentiation as economists? Why do we start differentiations as businessmen? Why do we start differentiations as technologists? Why? Why do we start differentiation? Very important question in the mind of any scientist or mathematicians. Okay, so here we develop the third question. Why do we start differentiation? Why do we start differentiation in our life? Why do we study differentiation in our life? So simply, there are so many reasons and there are so many advantages. But let me mention some. In real life situation, A-level students, are you following? In real life situation, ordinary diploma students, are you following? Differentiation may be applied in solving problems. Differentiation may be applied in solving problems concerning the following areas of life. I will mention some. Concerning population modeling. So, for example, we had a census, the national census in Tanzania in 2022. So there are some statisticians who did something we call it population modeling. We need also the concepts. Of differentiation, solving problems concerning about mechanical engineering systems. So you can solve mechanical engineering systems. Okay, we have motor vehicles, we have trains, we have aircraft. Also, you can solve civil engineering systems. Civil engineering system can solve real life problems concerning about electrical. When you say mechanical, including its subsidiary or sub-branches. Okay, so automobiles is there. When you say civil, it means constructions, building, highway, water engineering or irrigation engineering. When you say electrical engineering, it means about renewable energy engineering system. It means that just this is the big picture, electrical engineering system. But also we need the concepts of differentiation to solve problems concerning electronics. Okay, this is my beautiful field. Electronics engineering or small electrical current or invisible engineering systems. And also we need the concepts of differentiation to deal with communication engineering systems. Then we have, again, we need this concept to deal with scientific or solving scientific or science or scientific problems or scientific systems. Just let us say the scientific systems. Then we need this knowledge to solve different problems in economics. We need the knowledge of differentiation to solve different problems in business. We need the knowledge of what? We need the knowledge of differentiation to solve different real-life problems in research, etc., etc. So those are the some reasons for I and you to learn what is differentiation. So you want to understand or to model different economics, real-life economics problems. Yes, but I left one term now here, or one of the area, very important, number 11. Research. No, not research, financial. We mentioned 12. Financial, so we need the knowledge of differentiation to solve some financial problem or finance, right? And then number 12, we need this one to solve agriculture or agricultural problems, and then etc., etc., etc. So you can see we have so many reasons of learning what? Differentiation. Myself, I have so many reasons of learning differentiation from now onwards. How about you? Let me know in the comment section of this video. Okay, did you understand the reasons? Or where are you going to apply the knowledge of what? Then there are two branches of differentiation in mathematics. The first one is actual that differentiating different functions, and the second branch is applications. So we'll teach you some applications of differentiation. Okay, so that's all. So if you've understood why do we study differentiation, as how we've been taught it, why do we study physics, why do we study chemistry, why do we study biology, why do we study geography, and even in differentiation we have to teach you why do we study differentiation and why do we study integration, why do we study that. So if that's the case, did you understand? If the answer is yes, allow me to take you into the fifth part of this lecture. Do you know the fifth part is what? The first principle. The title of the lecture is the first principle. The first principle. Okay? So the fifth concept is called the first principle. The first what? The first principle. The first principle. Say with me the first principle. The first principle. Say it with me. The first principle. The first principle. This is a very important principle in my life and in your life. Because you've encountered it, whether you're dealing with single variable function, whether you're dealing with multivariable function, it's a very important principle in my life. And also it should be a very important principle in your life. Okay. So in this concept, we are going to teach you other three concepts, the introductions of first principle, and then we'll teach you about the derivations of the first principle, and then we'll teach about the notations of the first principle, and then we'll teach you about the problems solving or differentiating different functions by using first principle. So we have four concepts that we are going to cover. And I cannot manage to cover all of them. That's why I ask you to join me in session 2 or lecture 2. Okay, and session 3 and lecture 3, where I'll teach about the first principle. First of all, it's one of the beautiful principles that I've met in my life. Okay, so from here, actually let me start with 5.1. Okay, so it means the introduction. Introduction. I'll be calling introductions, I'll be abbreviating as intro. I believe even ECA students understanding, HG students understand what I'm teaching you. NTA level 5, mechanical engineering, you understand. NTA level 5, electronics and telecommunication engineering, you understand. NTA level 5 in civil engineering, you understand. all of these contents, whether in Dar es Salaam Institute of Technology or in Bear University of Science and Technology or Karume Institute of Science and Technology or Arusha Technical College, I believe we are speaking the same language, isn't it? Okay, so introduction of the first principle. Introduction of the first principle. First principle. Okay? First principle. So we have a fundamental question. And the fundamental question, this is question 4 that I asked myself. What the meaning of differentiating a function by first principle? Because if you are teaching about first principle, later on we will teach you how you can use first principle to differentiate different functions in mathematics, right? So this is the question number 4, right? What does it mean? What does differentiation, what does differentiation by the first principle, what does differentiation by the first principle mean? What does differentiation by first principle mean? What are the meanings of differentiation by first principle? That's the question. You can pause the video and try to answer this question on a rough paper. Okay? Okay, so one of the reference define this one. Differentiation by first principle means, so the differentiation by the first principle, okay, is a process of determining the derivative or slope. The process of determining the derivative or slope of the function. Slope of the function by computing the limit of the ratio of small change, changes. So we said about a function by computing the limit of the ratio of the small changes in what? In dependent variable y to the independent variable x. The dependent variable x as small increment. As small increment. A small increment of x as small increment of x goes to 0. Goes to what? To 0. That's the meaning of differentiation by first principle, or finding the derivative by the first principle. Its meaning is what? Is a process of determining the derivative or slope of the function by computing the limit of the ratio of small changes in dependent variable y, commonly, to the independent variable x, this is for the matter of introduction, as a small increment of x goes to 0. So differentiation by first principle, we are going to teach you how you can find derivative or slope of the function by finding the ratio of the small change in dependent variable of the function to the small change in independent variable of the function as the small increment of independent variable goes to 0. That's all. Differentiation, what that means, so differentiation by first principle, simply it's a process of determining the slope or gradient of the function or derivative of the function by determining the small change in what? The small change in dependent variable of the function to the small change in independent variable of the function as a small change or small increment of independent variable goes to 0. So it's a process of finding limit. It's a process of determining the derivatives of the function by computing what? The limit of the ratio of the small changes in independent variable y to the independent variable of x as the small increments of x goes to 0. What are the key points here? Number 1, the differentiating by first principle is finding the derivative or slope or gradient of the function. That's the first key point. Number 2, also when we are determining the gradient or slope of the function, the technique that we'll be using is finding the limit, right? Computing the limit. Number 3, the limit of what? Ratio or small changes in independent variable of the function and independent variable. Key point number 4, as the small increment of independent variable goes to 0. That's all. So those are the 4 pieces of information. So just let me summarize, because it's a heart of lecture 1 and lecture 2. So just to summarize means that in summary, let me help you to summarize these corner points. Very important, and remember this for the rest of your life. What the means of differentiation by first principle? I said number 1, finding what? Finding gradient. Just like how we taught you to find gradient in coordinate geometry, gradient or slope or derivative as a new terminology that we taught you today. Derivative of what? Of mangoes? No. Of chairs? No. Of the function. Number 2, I said, also will be dealings when you find gradients or slope or derivations of the function. It means that we have to compute it. To compute limit, which we'll be using these notations, lim, in abbreviations. Limit of what? Limit of what? Of the function. But limit of what? Of the ratio. Then we get number 3. Ratio of what? Ratio of independent of dependent. Ratio of dependent variable. Okay? Dependent variable to the independent variable. So this is general to the independent variable. Right? So what does it mean? So ratio of what? Of small change. Remember that the ratio of small change. Small change. Of what? Of dependent variable to the small change of independent variable. So if the dependent variable is y and dependent variable is x, then determining of the differentiation by first principle to be means that changing in y over change in x, small change in dependent variable over small change in what? Independent variable. Then the first key point is what? As small increment. A small increment of what? Of independent variable. Dependent variable in most cases for your level of mathematics is x, dependent variable, or in most cases. Dependent variable goes to 0. These are the 4 key points that God has been building, has been teaching me over in my mind since I made with the concept of the first principle for more than 15 years. So he has been rebuilding in my mind. He has been expanding my mind. These 4 key points. And actually to make me to remember and keep and understand and apply the concept of the first principle for the rest of my life. These are the information written in my mind. And they are there always. I thank God by His own grace. Okay? So, I believe that now you have understood what the meaning of first principle or differentiating a function by using first principle. What I've been teaching you is what does it mean? I didn't teach you how you can do. I will teach you how you can do. And that's why that you have to join me in lecture 2 and session 2. So lecture 2 of session 2. Okay, so if that's the case, then we come into section 5.2 of this lecture 1 of session 1. You know, what are we going to learn right now? The very important concept, which you call it, but before that one, so I say that, yeah, so I think that I have to make sure that, okay, fine. So before I teach you 5.1, so he said that mathematically, this is, okay, literally, so mathematically, the meaning of differentiation by first principle is this, that we have slope, have something we call it slope, or gradient or derivative, because you are familiar with the word derivative. This will be equal to the limit. Okay, limit as what? As a small change in what? If the function, for example, this is, let's say the given function is the dependent variable is y and dependent variable is x, for instance, like this, right? For the single variable function. So you say that in the limit as small change in independent variable, which is x for this case, approaches to 0, then here we are going to have a rate of small change, a ratio of small change in dependent variable y over small change in independent variable x. So this is the general mathematical definition of first principle. So on the left hand side we have what? Slope or gradient. On the right hand side we have 3 components. The first one is limit, the second one is change in dependent variable, the function, and the third one is change in independent variable. Don't claim this is a fundamental. Later on I will teach about differentiations of multivariable functions. This is for the single variable function, right? So then you cannot find y there, you can find y in denominator and then find x in denominator, then we can have another variable. This is the foundation. I will update you later on especially when I'll be teaching about advanced calculus. Okay, so this is the mathematical definition of what? Of the limit of the function. Did you understand? No. Did you understand the meaning of differentiation by first principle? Let me know in the comment section below. Okay. So the next important concept is this. That this is 5.2. The derivation. So let me teach you how you can derive derivation of the first principle. Derivation of the formula of first principle. First principle. Derivation of the formula of first principle. Derivation of the formula of first principle. Derivation of the formula of first principle. Say it with me. Derivation of the formula of first principle. What are we going to learn? Derivation of the formula of first principle. Say it again. Derivation of the formula of first principle. We are going to derive the formula of first principle by following only 4, how many steps? Yeah, only 4 steps. Only 4 steps. Okay, so derivation of the formula of first principle. Okay, so in mathematics, we can derive the formula of first principle by following only 4 steps. Only 4 steps. Then, ladies and gentlemen, here's the first step. Are you ready for the first step? The first step, we ask you that sketch the curve of the single variable function. In mathematics, we have single variable function and variables function. Single variable function f of x. So sketch any curve. So sketch any curve. Sketch any curve. Any curve of the single variable function f of x. So we are going to sketch it and follow along. This sketch is very important, more than you think. So you can sketch any curve. You may sketch mine, you may sketch any other curve differently from mine, and you can derive the first principle. No limitation, should not cramp. However, that in mathematics, we might have a commonly used word curve, but it doesn't mean that first principle is only limited for that particular type of the curve. So this is y-axis. So this is our y-axis. And then here we are. This is our x-axis. Y-axis, and that is our x-axis. Okay? So then we can have, then we just have a parabolic function. Parabolic curve. I get the, don't think if I will get the, what? I need to get the line of tangent because sometimes we have to show the line of tangent. Okay, so let's say that we have okay. So here it is our curve ffx. Then we say that it's a sketch. Okay, so suppose that we have 2 points. Suppose that this is point A, and suppose again we have another point here, and this is point B. So for this point A, let its coordinates to be x, ffx. These are the 2 x and y coordinates. And let at point B, its coordinate to be what? To be x plus small increment in x, which is changing x, ffx plus small change in x. What does it mean? So listen carefully. So the input of this function here, the input of this function is x. This is the independent variable. X is what? Independent variable. Don't forget that. And then we have, so whenever we substitute the value of x in the function ffx, then we can find what? We can find it's what? We can find it's, so we can find it's what? We can find the value of ffx. So this is the value of ffx. Again, here we are. Okay, so this is point B. So point B, here our x coordinate is x plus small change in x. And then here we say that we have ffx plus small change in x. Okay, so this is our curve. But again, we can be interested to draw a line, we call it tangent, which we'll teach you later on. A tangent line is a line which touches the curve at only one point. So we need this tangent line because according to the third definition of the function, we say that in derivative we can be, or in differentiation we can be finding derivative or a tangent line in a particular direction. So suppose that this is the point of tangents, only one point, not more than one point. And let's call this point C. So it's a tangent point. So its coordinates are x, y. Okay, so there we have our figure 1. Okay, so this is y axis and that x axis. So this is, we call it figure 1 in labeling, figure 1, and then we say that the curve, so what is it? The curve of the function ffx. So that's the first step. We are done with sketching. Are you done for sketching? If you didn't finish, You can pause the video and then sketch the graph. Once you are done, press the buttons of continue to get into the second step of our derivation. Okay. So the second step of our derivation is what? Now, we say that let us recall the concept we taught you in basic mathematics for the Form 1, the concepts of what? Of finding what? Finding slope of the line. Okay, in what? In coordinate of the straight line, in coordinate geometry. So this is for the straight line, not for the curve. There's a difference between the curve and the line. Recall the concept of finding slope of the line in coordinate geometry. So do you remember how did we define? How can we find slope? Slope of a line, we say that is equal to ratio of small change in y over small change in what? In x. Simply, we call it or slope. For that point, we say m, we use notations of m, is equal to small change in y over small change in x. Then, once you recall it, so this you can call it equation 1. Compare it with the general or the mathematical descriptions of first principle. So we have slope here, and then on this side we have change in y over change in x. So what we are missing in order to have a first principle is limit. Wonderful. Mathematics is beautiful. The steady state. So the steady state. So if we have a formula. We have a formula. The steady state now we have to find the slope. Okay? So here we can also draw a straight line like this. So the steady state, are we going to follow 4 steps? Yeah, because, yes, okay. So the first steady state, we say that use equation 1 above to find the slope of line AB. So what is slope of line AB? So slope of line AB, for this case m, is equal to what? Change in y. So change in y, so we take the y coordinate, which is f(x). Let us do together. Listen first. f(x) plus change in x. This is the y coordinate. Minus the second y coordinate. It is what? f(x). Just plug it. Then we say divided by the first x coordinate, which is x plus small change in x. Small change in x minus, then we have a small change in x, which is x like this. Wonderful. Remember, during Form 1, we used x2, y2. So during Form 1, this we call it x2, and this we call it y2. Let me remind you, because some other students, they get confused. Why do we have f(x)? In Form 1, we didn't learn about f(x), we learned y. But remember, my dear students, that in mathematics, whenever we say f(x) is equal to y, that is. And this, in Form 1, we taught you in Form 1 and Form 4, because we teach coordinate geometry as the last topic or the 11th topic in basic mathematics for one, and I do teach it online. You can visit my other online school for ordinary secondary education. And also we taught you coordinate geometry as the first topic in basic mathematics for 4, and I do teach it in another online school that called Tanzania Online Ordinary Secondary School in square bracket Olenjolai. Okay, so this we call it x2 minus, so means the formula. So here we replace with y2 minus y1. So this is x1, comma, y2. Right? And then x2 minus what? x1. Okay, so now we have our formula of slope. We have the formula of slope. Have the formula of the slope. So here we have what? So slope of the line AB is equal to ffx plus small change in x. When you are writing, if you are not pronounced, keep this information in mind, over x plus small change in x minus what? Minus x. So open the bracket. Once you open the bracket, we'll have slope is equal to ffx plus small change in x minus ffx. Then open the bracket. Here you have x plus small change in x minus x. So then we have what? Slope is equal to what? ffx plus small change in x minus ffx divided by small change in x. So this, ladies and gentlemen, we call it equation 2. Whether you are studying basic applied mathematics, or you are studying advanced pure mathematics, or you are studying differentiation and integrations, it's mandatory for you to learn the derivations of first principle. It's mandatory. You can be asked anytime. Can be asked anytime. Simple derivations is not difficult. So we are in 32nd state. It means we are in 30th state. You know the first state, what are we missing from the definition of first principle? The thing that we are missing here, we have the rate of small change in 1 to the rate of small change in x. What are we missing? Limit. So the concept of the first step, we say this one. So it means that, remember that this is the slope of the line AB. This is straight line. This is the slope of the line AB. But our intention, we want to find the general formula of finding the slope of the curve. This is the curve. Remember that this we call the tangent. So let me label it. So this we call the tangent line. Right? And this we call the straight line. Straight line. And this we call the curve. Curve. Straight line, tangent line, curve. Okay, so if that's the case, we say that wonderful and powerful. Great. So what do you say that? I think that, okay, yeah, so straight line. So this is the straight line. Straight line. Okay. So if this is the case, ladies and gentlemen, so this is the gradient or slope of the straight line. But our interest, we want to find the general form of finding the slope of any curve. How can we combine the concepts of finding the slope of the line with the concepts of finding the slope of the curve? We should introduce the limit. It means we can find the slope of the curve at the point when we assume that point A approaches to point B in such a way that the curve from A to B will look like a straight line. What does it mean? This is the meaning. Suppose that this is point B. Let me teach you and then I'll write. This is point B. And then suppose point A approaches point B. Right? So suppose approaches somewhere here. This is point A, right? So it means approaches point A means that for this case now, the small change in x, because the difference from here to here is what we call the small change in x. So this small change in x. So it means the small change now for this case, if these 2 points are close, the small change in x will be approaches to 0, will be very small. And at this case now, instead of having a curve like this, the curve, instead of having a curve like this, then now if we join these two closest point, or closer point, or closest means closer points, then we can have like a straight line. So if that the case, we can have a straight line if we do such kind of assumption. That assume point A approaches point B. And then from there, if you join the curve, instead of having the bending line, we'll be having a straight line. And for that case, we can find the gradient of the curve. So by first principle, we can find the gradient of the graph between the 2 points when the small increment approaches to 0. So the first step, I know this is challenging. Watch over and over the first step, because I know it's a little bit challenging to understand. So the first step, we say that introduce limit of the function. Okay? In what? In equation 2 above, by assuming that point A approaches point B in such a way, let me write, in such a way that the line joining A and B is a straight line of curve f of x. So it is possible if small increment in x goes to 0. So simply, mathematically, okay, because we still need this curve, let me again here, believe that you are done with this part. Okay, so mathematically, we can summarize the information I gave in the first step as this, that limit as small increment in x approaches to 0. So that denotation, that's what you have to introduce. Limit as small increment in x, it goes to 0. So it means that as small increment in x approaches to 0, point A will be approaching point B, and the line joining point A and B of the curve will be a straight line. So as you say that, introduce the limit of the function in equation 2 above by assuming the point A approaches point B in such a way that the line joining A and B is a straight line of the curve, not this straight line. It's a straight line of the curve, right? It is possible if small increment in x goes to 0. So you say we have to introduce it here, right? We have to introduce it here. So this is not actual, it's an expression, okay? So it means that now if we introduce the concepts of limit in equation what? In equation 2, then we have what? Then we are going to have limit as small change in x approaches to 0. Then we are going to have what? F of x plus small change in x minus f of x divided by small change in x. Okay? Limit in mathematics, we can also use the abbreviations of lim, like this. So now, the general formula of the first principle is slope or derivative of the function. This is equal to what? Limit. So ladies and gentlemen, I would like to present to you the good news of the first principle. I have been teaching you how you can write the first principle, and mathematically we say that this is the way we write the limit at the first step. So we have to substitute this expression of limit as small change in x approaches to 0 into equation 2. So then we wrote slope. Slope is equal to limit over change in is equal to limit as small change in x approaches to 0. F of x plus small change in x minus f of x over small change in x. Remember this. Now, the general formula of first principle for the rest of your life will be written this way. Slope or derivative of the function is equal to the limit as small change in x approaches to 0, f of x plus small change in x minus f of x over small change in x. But this is only for single variable function, remember. In some books, some teachers, some lecturers, they used to teach the general formula of first principle in this form. So the other way that you can write the general formula of first principle is we can let the small change in x to be h, right? Once you have done that, now it means we can rewrite this general formula of the first principle in this other form. So slope or derivative is equal to limit as h approaches to 0, f of x plus h minus f of x over h. So whenever you have small change in x, you replace it with h. Okay? So this is the general formula of first principle. Did you understand? If the answer is yes, then let me know in the comment section. If the answer is no, please ask me more questions in the comment sections and I will try my level best to help you. Well, so now I hear from my heart that God saying, Olenjolai, it's enough. If you continue more than that, you will overdose my students and I have to honor the voice of the Holy Spirit speaking in me. So for that case, I would like to say I'm about to end lecture or session 1 of differentiation, right? Titled as what in the first principle. So now, but before I leave it or before I end it, let me leave homework 1. The homework 1 that I will leave to you, which actually will be the concept that we'll cover in the next lecture, write 6 standard common notation of derivative notations, standard common notation of derivatives of derivative of the function. Write 6 standard common notations of derivative of the function. That's what we ask you of the function. This is your homework. And this will be example 1. Yeah, example 1, because it's the question. Example 1. Write 6 standard common notations of derivative of the function. So write. If you fail, don't worry. I will teach. I will do the corrections of homework 1 in lecture 2 or session 2. Right? If that's the case, did you understand everything that I've taught you in lecture 1 or session 2? In case you didn't understand, watch this video second time, third time, fourth time, over and over until this concept is built up in your mind. Because for me, I've been learning the concepts of first principle for more than 15 years and it's still in my mind. Right? In case you have any question, don't hesitate to ask in the comment section. If you didn't subscribe into our official YouTube channel, then do it right now. And in case that also you like to share this good news to other online students, then you're allowed to do it right now by clicking the icons of share below of this video on my left hand side, but it's on right hand side for you. Keep inviting more students to come and enjoy the beauty of digital education. And again, in case you feel from your heart that you like to offer your freeing thanksgiving or freeing offering to our Almighty God through this program, don't hesitate to yourself. You can do it through this telephone number, 0759745331. You can send, means you can offer any amount of your offering or any multimedia equipment or any supporting any materials that can be used to just to change radically the life of Tanzanians, Africans, and the entire world in secondary level and university level. So you can offer your feelings and send it, and then I tell you that you'll be used to pay for the running cost. But before you do that, go through these 2 scriptures, regardless of your religions and denomination. Those 2 scriptures are the one gave me permission from God to invite you for this great generational work. If that's the case, again, in case you feel that you would like to offer books, notes, and materials of advanced pure mathematics or basic applied mathematics or basic engineering mathematics for ordinary diploma or basic scientific mathematics for ordinary diploma, don't hesitate yourself to send to me an SMS through this telephone number 0759745331, and I will call you in order to accomplish the business as well as we can. This is the end of lecture 1. It's the beginning of preparations of lecture 2. Before I end, let us have Omega prayer for lecture 1 and give God His greatness and a mind. So our Father who is in heaven, I come before your presence as your son, as your child. I come before your presence. I say thank you on behalf of all my online students, and I join with them right now with a thank for the great things and great revelations that you have been seeing or experiencing in lecture 1 or session 1 of differentiation. Thank you for teaching us the first principle in different way and different style. Keep teaching your students and distribute these contents to the entire country of Tanzania, to the entire African continents, to every regions of Tanzania, Father. Thank you because you are faithful, and thank you because you are mighty God. And I give you thanks because your loves in lecture or session 1 endures forever. Thank you for your greatness. Thank you for the students that you have given me. Thank you because all the glory and honor will be yours in everything that will be done in this online Diploma Polytechnic Institute of Tanzania square bracket Olenjolaim. All the glory and praise will be yours for everything that will be done in Tanzania Online Advanced Secondary School in square bracket Olenjolaim. Father, bless our country Tanzania. Bless the people of Tanzania. In Jesus' name, amen. May God bless you. Keep enjoying the beauty of advanced mathematics. Keep enjoying the beauty of basic applied mathematics. Keep enjoying the beauty of basic engineering and scientific mathematics for ordinary diploma. See you in the next session.
Mungu ibariki Tanzania